Good day, everyone. I'm Celine from 11B, and today I'm going to explain about geometric distribution, which is a part of Cambridge AS Level 9709 Statistics 1. First, to start off, let's do a little introduction on the topic. Geometric distribution. What exactly is geometric distribution? It might sound complicated, but let's break it down together step by step. So, a geometric distribution is a discrete probability distribution. The discrete random variable follows a geometric distribution if it counts the number of trials until the first success occurs for an experiment that satisfies the conditions. What conditions? There are four important conditions for a geometric distribution. First one, there could only be two possible outcomes to each trial, either success or failure, with fixed probabilities of P and Q is just basically 1 minus probability. The second one is that all the trials should be independent of each other. Third one, the probability of success P is the same in each trial, and the last condition is that the trials continue until the first success. Next, here are the formulas for geometric distribution. First, probability that x equals to n, which is probability times 1 minus p, which is q, to the power of n minus 1. And this is the probability that the first success occurs on the nth trial, and geometric distribution can be written as x dash q to bracket p. Second, probability that x is bigger than n, which is just q to the power of n, and this is the probability that it takes more than n trials. Next one, probability that x equals to or less than n is 1 minus p to the power of n, and this is the probability that it takes less than or equals to n trials. And the last one is that the mean is just 1 over the probability. Here are the key terms. So P is the probability of success, Q is 1 minus P, probability of failure in one trial, and N, number of trials up to and including the first success, and N minus 1 is number of failures. So without further ado, let's dive into some example questions to get a better understanding of the topic. First question, in a large population of school students, 30% have taken the math test. The students from this population are randomly selected. What is the probability that the 6% that was chosen randomly was the first student to have taken the math test? So, the question asked us about probability when n equals 6. From the question, we know that the probability is 30%, and we can convert it into decimals, which is like 30 divided by 100, which will be 0.3. Next, we will input our known data into the first formula that we learned in the previous slide. So, probability x equals 6 is probability 0.3, 1 minus 0.3 to the power of n minus 1, which is 6, minus 1, which is 5, and then we input that into our calculator and we'll get 0.0504. And don't forget to correct it to three significant figures. Moving on, we are going to do a question from a past paper about geometric distribution. Number one, the score when two fair six-sided dice are thrown is the sum of the two numbers on the upper faces. A. Show that the probability that the score is 4 is 1 over 12. So we can get a 4 only from the sum of 1 plus 3, 2 plus 2, and 3 plus 1. And each of the probability is 1 over 6, since from the question we learned that it is a fair six-sided dice, so the probability will be 1 over 6. Here is the solution. So we can just multiply them, multiply all the possible combinations, and we'll get 1 over 12. Hence, it is proven that the probability of getting a 4 is 1 over 12. Next, the two dice are thrown repeatedly until a score of 4 is obtained. The number of throws taken is denoted by the random variable x. Find the mean of x. To find the mean of x, since this is a geometric distribution, we can just use the formula we learned before, which is mean equals to 1 over probability. since the probability of getting a 4 is 1 over 12, and we got this from the previous part, the A, so it will be 1 over 1 over 12, and from that we'll get 12, and that is our final answer. Next question, C. Find the probability that a score of 4 is first obtained on the sixth row. Here, we have to find the probability of getting a 4 the first time on the sixth row. That means the probability of x is equals to 6. Next, we can use the formula and substitute the values. This is the formula that we will be using. And so the probability of x equals to 6 is p, which is 1 over 12, and 1 times 1 minus p, which is 11 over 12, to the power of n minus 1, and our n is 6 minus 1, which is 5. And then we'll input this into our calculator, and we'll get an answer of 0.0539. And don't forget to correct it to 3 significant figures to get the accuracy mark. Last part, we are asked to find the probability of x less than 8, which means like 7, 6, 5, 3, 2, and so on. So we can write this as x less than or equals to 7, as it basically means the same thing, and input it into our third formula that we learned today, which will be probability of x equals to or less than 7, and then we'll input this into this formula, 1 minus bracket 1 minus probability, which is 1 over 12, to the power of 7. Don't forget that our n is 7, since we're going to use the less than or equal formula, and our n is not 8 because this one is a less than. So please don't forget and mix that up. And from there, we can get 0.456 after we put this into our calculator, and once again correct it to 3 significant figures. And with this, we have reached the end of the explanation on geometric distribution. I hope this helps, and thank you so much for listening, and have a great day.